Okay, everyone, thank you. We're going to go through a live demonstration of the DranXperT user interface. And again, as I said before, this happens to be a DranXperT that's cellular connected, but this can be connected anyway to your computer via just a direct cable, just a hardwire directly from one to each other with the Ethernet connection. Once your DranXperT is on the network, well, then you have the ability for Wi-Fi, any other type of connection, and with any type of access with VPN on the internet or whatever. So it's certainly your option on how you handle the connectivity for that. Okay, here is the DranXperT homepage. When you first enter the IP address of DranXperT, and you have not logged in before, you'll be asked for a simple username and password. And the username is admin, and the password is Dranitz with a capital D. That is the default that it comes from the factory. You certainly have the ability to go change that through this user interface. Well, this first page that you see, you can consider it a home page, even though if you go to information to get back to it in the future, it's called the status page. Effectively, it's the home page of the meter. Primarily, this gives you status information of the meter, the model number, the serial number. So if you communicate with our technical support folks for anything, they're going to probably ask you what the serial number is. There's the version of firmware in the product as well as some other information, such as what is the name of this survey that you're now presently recording, or if recording monitoring is off, what was the last survey that you've recorded? The status of the monitoring. Monitoring happens to be off right now. If it were on, it would say on. And down at the bottom, I'll just skip around a little bit, you can see there's a control button. So monitoring is now off. If you want to turn it on, you simply hit this monitoring on icon. The unit will beep. If you're near it, you'll hear it. And then this button here will change to turn off monitoring. And again, the status will be shown accordingly here. So that's kind of the major aspects of this. And as you get down, it'll tell you whether it's running on battery power or the line power. This happens to be line powered right now. If we went to my office and pulled out the AC adapter for the meter, then this would go and say battery powered at that time, as well as giving the charging indication. And this will tell you the battery level as the battery is discharging or charging back up again, as well as language. We have a version that's about to be released, which is now available in all of these foreign languages. And thank you again to our partners who helped us translate to these languages. So we, of course, have English, German, French, Italian, Spanish, and both simplified and traditional Chinese. As we evolve and our partners assist us, we'll add other languages as well. So we hope to add more in the future. And you simply, through this control, you just pull down, select the appropriate language, and now the user interface will be available in that particular language. So again, this is the instrument status page. So for the most part, you're just going to be interested in the monitoring status and things like that. But again, there'll be some diagnostic information on this page that our tech support may ask you to go supply as we're helping you through some configuration or other issues. So we have other tabs over here that are important to the setup of your survey, the data review and download of your survey, as well as some factory capabilities here, which we won't spend much time on, but you can see here's to change the password. As I mentioned before, from time to time, and probably in the next week or two, we're gonna have a new firmware update. This is where you update the firmware, you in effect download it from our website, put it on your computer, and you go through a short wizard here to update the firmware, which is effectively downloading and transferring it from your computer to the DranXperT meter, and then instructing the meter to install it. It's that simple. So, as well as some other things to adjust and adapt some other things, and as well as maybe restore the meter to factory configurations if you get lost, and there's several options for that. And also to restart the meter. If you think there's an issue with it, it gives you the ability to restart it, and again, when these meters are remote, this is a nice way to remotely restart it. You don't have to go to the facility, wherever it may be. So we're going to kind of work from left to right here. And the primary tab here is the setup tab. And again, if you've not set up the meter, this is going to be quite important for you. And really, there's four options here that are the most important, where the survey tab is monitoring your primary power survey and how you set up the meter for that, what's your wiring configuration, things like that. Instrument setup is kind of some housekeeping on the instrument, how long to keep the database, things like that. And we're going to go through these individually. The date and time, so setting it up for daylight savings time. Other things, what is the time of the meter today, and also time zones, as well as the expansion setup tab. Now, this will be grayed out and not available if you do not have the version with the sensor inputs. If you have purchased the version with the sensor inputs, this will be a live tab, and this is where you enable the monitoring for those sensors, and you also configure those sensors, okay? As well as the meter has the ability to save setup files, templates, and upload them again. And we're going to focus on these first four. I apologize, they're disappearing. These first four setups. So we're going to go to the survey tab. And it's divided into several areas here. And this is most importantly, is your survey name. You could type in anything you want here. We always suggest with our products that this relates to the point that you're monitoring in your system. You can make it any name that you'd like, although. Nominal frequency. Well, this is where you choose 60 hertz here in North America, most of Latin America, or 50 hertz if you live in one of those countries. So you have to tell the meter what the frequency is. Most importantly is the wiring configuration. So single phase, which is the demonstration that I have set up nearby, split phase, 3-phase Y, and then either a 2 or 3 probe delta, which these are really the same measurement wise. The only difference is with the 3 probe delta, it'll provide current for what your line current is for phase A, phase B, and phase C. Really, to do a delta measurement, you really only need 2 probes to do that. And that's what this other 2 probe method is for. So you only need 2 probes to properly measure the total power in a delta circuit. But this third one gives you the option, if you just want to meter what's going on in all 3 phases, it gives the ability to display that to you at the same time. Some other things like checking off, do you want to re-enable monitoring when the instrument powers up? So example, maybe the battery fully depletes and then AC power is restored again. The meter will start back up, start charging the battery, but most importantly, it'll resume monitoring where it left off, okay? Pre-trigger cycles. This gives the ability on any of these voltage and current settings that you see below, how many AC pre-trigger cycles and how many AC post-trigger cycles can be recorded. And you'll notice I didn't point it out before, there's a little help next to everything, kind of give the ability to know the range of measurements that are allowed for you to be entering into these configuration boxes. If you enter something out of range, you will not be able to submit your changes. So it'll remain grayed out, and you just have to look to see which one is out of range or is an invalid entry for this. So continuing along, you have the ability to independently enable voltage monitoring and current monitoring. And by monitoring, I mean, whether you're going to set it up and what your primary voltage is, what your CT ratios may be, or I'm sorry, PT ratios in this example. You can tell the meter whether it can identify any sequence changes or sequence errors when you're wiring it. And like as an example, you wired it ACB versus ABC, it can identify that. And also very important, whether you want to trigger on voltage limits. And that's that PQ detector part that I mentioned before. So if this is checked, as it is for this demonstration that I have set up, you can set a high limit as a percentage of the nominal that you enter here, or a low limit as a percentage of that same nominal. So this is 120 volts in this example, plus 5%, which is a high limit of 105%, and minus 10%, which is a low limit of 90%. Okay, so you can enable that, and it comes, I think, from the factory default to that unchecked or not checked. The input order the defaults to ABC. You have the ability to change that with all the different combinations. 99 out of 100 customers probably don't need that, but that is an option for you. Now, also, you have the current monitoring. And again, to monitor power, you need voltage, you need current. As we mentioned before, the question determined, voltage is an absolute necessity for the meter. You have to measure voltage. Current is somewhat optional, okay? So you can be a voltage recorder, but to do power and current, you, of course, need to measure that current. So this is where you set up the information about what is the nominal current being measured, what is the probe type. So you have all the different types of CTs that we offer direct from DranXperT, as well as a custom selection where you can set up the meter for other types of CTs that maybe we come out with in the future. Or again, if you bring your own CT with a 333 millivolt output, will be compatible with that. And then you have some scaling that you may want to apply for that custom setup to scale that into the proper range where the primary is reading correctly. This is for any CT ratios that you may have. So maybe you're connected to another CT. You have a small, maybe one of our 20 amp clip CTs connected to a 5 amp secondary in a substation or in a facility. You have the ability to enter that ratio or the ratio of any CT that you may have as a primary to secondary. Now, the reason why this is in red over here is that this is to enable current limits. So if I check this box, I have the ability to have a high limit and a low limit for the current measurements. That can be very productive, but there's also some risk in that. And the reason being, it's not the meter's risk, it's the current varies all over the place. So you have to be careful because loads are coming on and off continually and switching. You may just get a lot of triggers that are unnecessary for you. So certainly it's an ability for this meter as it is our higher end PQ meters. But the same warning goes along this meter as with like an HDPQ as an example. Just be very careful when you enable current triggering that you don't get a whole bunch of false triggers because of the reasons that I mentioned before. So continuing along, you have the energy settings, whether you want to measure energy. And when you do so, what is the demand interval and what is the subinterval for that? And you can even set up a demand limit that once it achieves that limit, it'll light up an LED on the front panel of the meter, just to give you a visual warning that your demand has gone beyond a particular pre-programmed limit. Maybe that corresponds to a demand surcharge on your energy bill or something like that that's important to you. Now, like the other DranXperT products, this has the ability to do journals and snapshots. And what a journal is, it's basically a timed recording that the meter has. And as an example, this meter is set up for every 60 seconds. So every 1 minute, it's going to record a journal event in the meter. And this is very similar to a journal event for our HDPQ or our other legacy products that are older than that. That means every minute it's going to record all the measured parameters as trendable parameters in the database. So when you go view the data in DranView or DranView XP, you'll have a nice trend of your plot over time. So if you measure for a week, a day, you'll see a day or a week trend of all the parameters, the watts, the VA, the VARs, the power factor, demand energy, and so forth. Now, what the snapshot enable means when enabled, it's like a waveform snapshot in an HDPQ product. So at this interval over here, okay, every 600 seconds, okay, it's going to record a waveform snapshot. What that means is that one cycle of the 3 voltage and the 4 currents that are measured by the meter. So you'll see an AC waveform recorded every 600 seconds in this particular example. So you can set these two values to be exactly the same, or maybe to save a little bit memory, you basically make your snapshots a little bit slower if you don't need that information to be recorded as frequently. There's a big value in this because these snapshots not only give you a snapshot visually to see what's going on in your system, but you also, when you run the full version of DranView, primarily DranView Enterprise, you have the ability to take that AC waveform and generate harmonics and other information from that digitized data from DranXperT. So again, when you've done all of your configurations, this will light up over here and you click the Submit Changes button, or you can click the Discard button and not save them. So if you want to save them, press the Submit button. This will light up in blue. Like as an example, if I just check a button here, okay, you can see I can submit them or I can discard them. So I'm going to discard them. I don't want them because I don't want to change my setups. Then we go down to the instrument setup. So we'll just let that load. And that's miscellaneous information about the meter. Most importantly, the IP information. The meter ships with the default IP address, which will be your initial forms of communication to the meter. There's a simple procedure in our quick start guide that can help you through that if you don't understand the basic networking that's involved. Once you communicate with the meter, you can change it to any other static IP address to go on your network or be compatible with your system, or check DHCP. And DHCP which happens to be checked right now because this is the compatibility for that cellular modem. That means basically in human terms, that means get the IP address from the network. So the IP address is how you find the meter on the network. And this just says, well, the network gives that to the meter. So the meter turns on, the network says, hey, this is your IP address. That's the IP address that you have to use from that point on, okay, from the system. And, you know, again, when you uncheck this, you can enter any IP address that you want. And this is the, that's the factory default that's listed here, but you can override that and submit those changes and just change the IP address to anything. So here's the input channel. So I showed you earlier the LEDs on the primary measurement panel right below the current connections. You could change the color. It defaults to a standard DranXperT red, yellow, blue. However, you can change that to any combination, and you can make it any color that you wish, and maybe that matches the wiring configuration or the wiring standards for your facility. Now the database information, there's two settings here. The first one is how long in seconds, okay, or in pre-can time here is your database. And I think before I had a month, okay, so we'll set it for 1 month. This means my database will grow to 1 month. When I hit that month, it'll start a new database automatically, which is a month long. So it allows you to control the size of your database. So maybe you can, if you're going to do, you know, certain surveys like the NEC survey that's 1 month long, you could say, okay, I only have a month of data. I don't have to take 6 months of information or 2 months and cut it down to something shorter using our software. So this is the amount of time that your database will have data for, and you can do any custom thing in seconds if you wish to do it, but most people will do one of our pre-canned hours or days or weeks or month. The second setting here is how long the meter will keep your database in minutes. So here I set what is the time duration of your database, and again, we'll go to 1 month. This is, well, once I created a couple databases, how long can the meter maintain those databases? In other words, they'll expire. The meter has the ability to delete those databases after that time. And the reason for that is to just free up space for new databases that come along. Now, each meter has 4 gigabytes of memory, most of which is available for your storage. So you're really not going to fill up the meter unless you use it for a very long period of time on multiple surveys and don't maintain it and don't delete the older data. So basically this says after 3 months, my older database, my database can be deleted by the system automatically. Okay, if you don't want that to happen, you can change it to anything up to 2 years. All right, and then your data will be maintained. Just if you don't maintain your database, you run the risk of the meter filling up, I guess is the downside. Now here, at no additional charge, there's a BACnet interface, which you can enable and have the BACnet's device ID, but more popular is a Modbus. There's a Modbus map for the meter that you can enable here and put in your Modbus port as well. Okay, and 502 is a most common one, but you can put in any Modbus port that happens to be configured in your system. Like any page, once I've made my changes, I do submit change, and then it'll start record. Next time you turn on recording, it'll be recording with these changes. Or as I'm going to do, I'm going to discard the changes because this is just a demonstration. Continuing along, we have the date and time set up. Okay, so when we view this, this is just quite simple. This is what is the current date and time of the meter. You can enter that as well as the date and time format. You can go in the US, month, day, year, or some of the international methods, you know, maybe day, month, year, or start with the year. It's up to you. And that's how it would present the data on the user interface for the web browser interface that we're looking at right now. This is where you would disable daylight savings time. The US just changed last week. I understand Europe and other parts of the world will be later in March. And this is where you'd set the time zone. You can see here we're set to Eastern US time. So you would set this to whatever local time zone that you have. Just note, all the data is actually recorded in UTC time, but this tells both the meter and the software how to offset it and change that and present that in your local time. So this worked kind of in a similar manner as the other DranXperT products do. So again, any changes, I'll just hit this temporarily. You would submit the changes to start recording with those changes, and or just click discard if you're not interested and you made a mistake, or you could just change the tabs and it'll just go away. So the last tab that we're going to talk about is the expansion tab. And we'll just let that show up. And this is the newest tab. You may have attended some prior DranXperT training, but this is new. When you purchase DranXperT with the optional sensor inputs and transducer inputs, this tab will be viewable for you. Otherwise, if you do not have these options, that will be grayed out. So here's where you enable the GPS time. You check it to enable it, you uncheck it to disable it. And basically what this means over here is match the system time to the GPS. So get the time from the GPS. This is not unlike the HDBQ with the optional GPS module in it as well. All right. And also you have the ability with the GPS to journal the location. So once you enable this, not only gives you time, it gives you the location of the meter in XY coordinates or longitude, latitude coordinates, which I'll show you in a few minutes. All right. So this is rather simple here. Now, this is the major crux of having the sensor inputs, and this is the analog and digital input configuration. And you would enable it by checking this box. Here's where you set the journal information for, this one line for the analog and digital inputs. And what this means is that every 60 seconds, I'm going to take a snapshot, very much like the primary journaling that we talked about for voltage and current. I'm going to take a snapshot of what are the status of all my analog and digital channels here. So a total of 6 channels are going to be recorded in parallel. You may not be using all 6, but they all come together. And you can see I have one enabled here, for our demonstration that I'll get to in a few minutes. So pre-trigger and post-trigger samples. Now, this is not doing AC waveforms and things that the primary voltage and current. And so pre-trigger is similar but different, and post-trigger is similar but different. So this is in number of basically digitized samples that we're talking about. So what this means over here, when I generate an event here, and I have high-low limit capabilities. I'll get to the details in a minute. So when I do achieve one of those triggers, how many samples before that trigger, pre-trigger, do I want to record? In this case, it's 1,000. And how many after that trigger do I want to record? In this case, it's 3,000. So in this case, I'm recording a total of 4,000 triggers or 4,000 samples on this particular event. And you can see that's the maximum pre and the maximum post. You'll probably want something less than this, but this is what we have set up for a demonstration. All right. So when we talk about the analog channels, all right, again, there's 4 analog inputs that are available to you. You can change the name of those, and you can see I have a simple Ross Office test here, but as I can demonstrate, you can change this to anything that you want over here. Okay, so you can change them to anything that matches what your application is. And that's important because this is going to be the name that's going to be associated with the journaling and the events in the database. So you'll be seeing this in the DranView or DranView XP software. You also choose the type of channel. And by type, I mean, is it on or off? We recommend you turn off everything that you don't want. Or is it a 0 to 10 volt input? Or is it a 4 to 20 milliamp input for the meter? So this, of course, has to match the output of your transducer. So again, this is generic. We don't really care at this point what type of transducer it is. As long as it can produce one of these 2 types of outputs, that's the only important thing. So as you continue left to right, you're basically setting up the details of that sensor. Well, what's the minimum that can come out of it? What's the maximum in voltage that can come out of it? What are the minimum in units? Okay, the minimum in units. And what are the names of those units? So you can make it anything you want. As an example, I'm just measuring voltage here, and I'll show you an example of it. I could have did it voltage. I did sim here. So more practically, this would be temperature. This would be humidity, pressure, flow, whatever you want to name that particular transducer, which probably correlates to the name or the type of that transducer. Now you have the ability for high and low limits. So you can see I have the limit enabled here, and you can see they're disabled for the other 3 channels. And this is just in volts here, just because I'm not scaling anything. And this is that dial box that I showed you earlier on my simulation that I have set up. You can see I have a high limit of 6.5 volts, a low limit of 3.5 volts. And I'm going to show you when we're done with this demonstration what that looks like in DranView when I've triggered those limits. So again, the system based upon the journaling will trend those parameters over time. So if I'm monitoring temperature for a week, excuse me, I'll see temperature trended for a week. However, if my temperature goes above and beyond or below, and in my preset values here, these triggers, it'll record that as an event in the database, not unlike our HTTPQ records a power quality event. Different resolutions, but the same concept you'll get. It's like a journal event on an HTTPQ if you're familiar with that product. Okay, so and you would set up each of these channels individually, and you can mix and match the voltage output or the milliamp output on your sensors. So you're not locked into any type on any channel. You can randomly select that. Now, very similar for the digital inputs, you can apply any name that you want, and they're of different types. You can do a counter, an accumulator, so you can just count pulses. You could do a limit trigger where you could see whether it's basically a logical high or logical low. It's triggered on, off, high, low, whatever you may want to name that. And then you have a rate of change or state changes for them. You have the ability to basically go and really the difference between these two, if things are going to be changing very slowly, you do a low rate of change. And this is based upon journal intervals. And if you want something that's changing at a very high rate, this will be going on actual changes to the digital input measured and digitized. So as you go through, you can enable each one individually. Clear means when you start monitoring, it'll clear out any pulses that you had before for that particular channel. So if you've done a survey, you stop monitoring and you've counted a particular number of counts on a channel, when you start monitoring again, if this is checked, it'll clear that and make that 0. Otherwise, it'll continue to accumulate. All right, and this is where you enter the limits and the counts, or the units rather. And this can be in counts. You can make this your energy parameters, the flow or gallons per minute if you're measuring the water rate on a water utility, something like that. So again, these are very, very common types of settings that you would have for just generic transducer inputs. So that's really it for the setup tab. We're going to go to the data tab, and there's really only two things here. First is the real-time meters. And the real-time meters show you all the traditional, what are the energy, demand parameters. These are all in real time, updating every couple seconds. So what's your frequency, your voltage, your current, your power, all the common things, down to demand. And these are real-time information for the analog and digital inputs that we spoke about. So if you were measuring counts, I don't have it in my demonstration setup, but it would show you the counts as it accumulated. It would also show you the present state of that digital input. Is it on? Is it off? Is it high? Is it low? Whatever that may be. Now, this is that analog simulator that I showed before in my office. And if we were to go in my office and change that, you would see that go up or down depending upon what we're doing. And as I mentioned earlier, when I showed you the picture, it was set to 4.3 volts. Well, the meter's seeing it as 4.32 volts. All right. So again, that'll change, but this is where you'll see this will be scaled into temperature, humidity, whatever, however you've configured it over here in the setup for the expansion tab for the type of transducer that you've connected the DranXperT meter to. And again, that's available for all 4 analog channels. I just only happen to have one set up here. Now, when we talk about the GPS, again, I mentioned GPS is used for time synchronization, but it's also for location. So this is giving you the longitude and latitude coordinates, just like your Google Maps would do, for where this meter, where that antenna is located. And really, my office is to my left here, and really the antenna is right over there. So if you click this hyperlink, and you're seeing it change, you'll go to a Google Maps, okay? And here's DranX over here. So it's getting it right over here, okay? And so you can see exactly where that's located, all right? As well as you could do altitude, it's doing speed, it's just kind of noise here. And for diagnostic purposes, it's also showing you the number of satellites that it's found. Okay, so you might want to look at that. I think it needs at least 3 satellites to triangulate. But sometimes if it's cloudy, you're indoors or you're not near a window, these are things you may have to look at if you're not getting a good GPS sync. And you will know it because you will see the actual information light up here. You'll know you're synchronized to GPS. And just a couple other housekeeping things. Again, we mentioned the update the firmware. This is update the expansion module firmware. It's a different module of the meter, as well as resetting to factory defaults. We're not going to go through this, but you have the ability to reset to factory defaults. You get lost, you don't know what the settings are, you can wipe it out and it restores itself to the way it came to you in its box from the factory. But there's several options. This is keeping the IP address because you don't want to lose the IP address if you're communicating with it. This is doing everything, keeping the IP address, but purging all of the data. So this first one is settings only. This is settings and deleting all the data. And this is complete, including the IP address. So this totally wipes it clean, exactly the way you get it from the factory. Default setups and default communications. Restarting the meter remotely and also changing the password. All right. And that is the DranXperT user interface.